Today we're going to see this creation of the models for mechanical systems, and what we're interested is in the process on how we actually generate the model step by step. So we have this problem, as you can see on the screen. I put the title in there, Crash Test Simulation Procedure for Generating the Model. We have a situation where this vehicle is going to be subject to a crash test here. The idea here is that we would like to design the bumper and of course the front of the car in combination with the seat belts to protect the occupant. That's the objective of this. So how do we start creating this model? I get this here. The model here, the first thing we gotta do is to recognize what elements we have. So I am going to make a write-up and says step one. Let's just call it step one. And we'll say recognize the elements present on the system. The reason is that in here we need to identify the physical elements that we have and relate them to the symbols that we use to produce models using bond graphs. Like for example, in here, this spring in here is going to be a C element. This is going to be an R element. The car, this mass would be an I element. And you have the dummy here, which also be an I element. And you have the seat belts, which have a combination of the stiffness and damping. So that's the idea here. Okay. So we have this to recognize the elements on the system. The second step that we're going to do, we're going to call step number 2. Step 2 is going to be use a one junction for every distinct velocity on the system, including the reference, which would be the reference would be the wall. This simulation needs to take place at the time of impact. So we could move the wall towards the car just to make sure that we're on the same page, that the simulation starts when the car makes contact with the wall, not before. Okay? So I'm going to draw a line to that effect just to make sure that we're on the same page. I'll just draw it over here, but let's see what color we get for the line. That's where the wall is. Maybe see if I want to change the color. No, we'll have to leave it like, well, fact is that I chose to draw it. Otherwise, with a pen, I can change the color. But I'm gonna do it in here just so that you can see that the wall is right here. Huh? Yeah. We just do a good job here. We didn't do it right. So I'm just gonna go again. I'll just do my drawing here. Pen, red pen, and then we're gonna go and do the line again. Okay. Well, we'll fix this. Have to do it again. Well, all I was trying to say is that this the wall is right there. That's where it's going to see, but we have this. All right. So we have those. So use the one junction for every distinct velocity on the system. And so what we're going to do is let's just go ahead and here. This is a velocity of the system. Just gonna call it the one junction for the velocity of the mass like that. The wall here, in fact, is also a velocity because it's a reference velocity. I'm going to call it velocity of the wall like this. And then we have this, the velocity of the person here. I'm just gonna use another junction in here. We're gonna go 1, and this velocity of the person or dummy, yeah? So we have done step number 2. Then step number 3, that we're gonna say is, step 3, attach the elements that move with those velocities. All right? And so in doing that, we have the car that actually moves with those velocities. I'm going to change pens in here. So in here we have this I element, which signify with parameter value big M. We also have this other one, which is the person here with value lowercase m. Then we have the source of flow with velocity of the wall equals to 0.
So how do we know it's a source of flow as opposed to a source of effort?
Because this is a velocity, we are specifying that the velocity is 0.
Okay.
So this is a source velocity here. And so we have this, okay. Now, you can make the wall crash into the car or the car crash into the wall from the mathematical point of view. It's easier in our logic to make the car crash into the wall. So the power is going to go from the car into the wall, and you see this way. So one thing that we have to do next, this is just the power flow, and this usually is into the elements, but we'll clarify that in the next step. So we're gonna say step 4, create the velocity differences using zero junctions and represent that difference with, that relative velocity would be better, and that difference, or relative velocity with one junctions. So if the wall is static in there, the car crashes into it, and therefore these elements that are in between the wall and the car are going to see the difference between the velocity of the car and the wall. And the way you do that is using the zero junction, as I mentioned, and you say this is the velocity v sub 1 minus velocity of the wall. That difference we represent it with a one junction. Yeah, and the same thing we go in here. The car moves, and then these elements are in between, so they actually experience the relative velocity in there. So you could say, okay, look, this is the difference here is going to be using a zero junction. And this is going to be 1, which would be velocity of the car, big M, minus the velocity of the person. And we have done step number 4. And step number 5, remember this, step number 5, attach the elements that move with the relative velocities, or those velocity differences, and we basically are done. And in here you could say the elements that see with this relative velocity here are the C element, and then of course you have an R element also right here, damper. And in here, up here, this too, you have a C element with value 1 over case of 1, and you have also the, right here you have the R element with value b sub 1. And I think the only thing left to do is basically finish. You could say, you could just say then simplify and complete power flow. Yeah, that would be the end, which is what I was doing. So if this is the situation is in here, you have it in here. So what we have ended up is this is representing the wall. This right here is representing the bumper. And this is representing the car. And this one is representing the seat belt. Okay. This model as it is can be entered into the CAMG software. Now, we could number this thing and assign the causal marks, but if we have CAMG, we don't need to do that. CAMG will do it for us. What I would like to do is just number the bonds. I'm going to use, I think it warrants to use a different pen. So we'll go with this one. So, okay, the power flow, it's already all defined. See, power flows into the elements. So only here is the, you have a bumper here. So we could just number them. 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9, 10, 11, 12, 13. There are 13 bonds. But could we simplify some? The answer is yes. But you don't really need to. This could become just 1. Because you see in here we have the bumper as a group, we have the seat belt as a group, the car and everything. I number them not because it is essential, but so that everybody has the same graph and you can refer to the same variable names. Because the computer generates variable names based on the system itself.
Right.
Yeah.
So the C on the bottom, that would be 1 over K2.
Yeah. So in here we will have this would be 1 over K sub 2. This R is this B sub 2. Yeah. I think we have everything correctly done. So we could just enter this into the CAMG software and then we'll get this done. So we go over here and we look. Right here. Okay, so go over here and then we're going to build it into the Okay, right here, we're gonna say file new. So I would just begin. Right now, it doesn't matter which way you start because with the menu, it doesn't make that much of a difference. So, but you have this is a 1, and also I like to do a bit of the skeleton of this thing. Yeah. So we have SF, we have the 1. Oh, I think I was doing the right thing. Sorry. This is the 0, and then we have to have the 1 again to do the structures in here. And then we have another 1 to this other side out here. And then a 0 up here. Okay. We don't have to put the whole thing. I'm just gonna deliberately do it so that you can see that this is very versatile. You could come in here and do the number 2. I'm following in the order that you entered is how you will get the thing. So like for example here C, I'm going to go from here to here, and then the R element is going to be from here to here. Okay, so this was number 6, I believe, here. 7 is the junction here to the I element, and then you have, and then you go to the 0. And so we have the 0 here, and then we still have those 2 1s. You have 1 here, you have another 1 on this other side. And can we do the 9 and 10? Yes. So we go the 9 over here, and then this other here, 9 and 10. Oh, okay. We still need to attach the elements. You know, you have the C element, which is 11 here, and then you have the R element, which is in here, like that. And then we have the 1 junction. Oh, we have this. You got the right numbers. 12 will be over here. No, that was 13. Because I want the 12 on the I element, I need to delete this and make sure that I am on the right track here. I think the one that was built too quickly was this one right there. So if I do this, then you need to put this here. Yeah. Okay, and this is how we complete the bone graft model for, I think we got it now. Oh no, there's only one more bond I need, and then we have finished. Whenever you see something red in there, it means it's not finished, but now it is. And so that's the way we create the model from scratch and how we enter it into the CAMG software.